So, good evening. Let us start with sum number 3, first part. Exercise 2.4, sum number 3, first part. Now, what is that sum? Find the values of x for which the following functions are strictly decreasing. The first sum, f of x is x plus 25 upon x. Let me explain. What will be f dash of x? It will be 1 minus 25 by x square. Now f is strictly increasing when f dash of x is less than 0. That is 1 minus 25 by x square less than 0. That is 1 less than 25 by x square. Multiply by x square, multiplying by positive number, so inequality does not change. So x square less than 25. Now how to solve this inequation? That gives me minus 5 less than x less than 5. Of course, x is present in the denominator in the original function. So I will say f is strictly decreasing if x belongs to open interval minus 5 5 excluding 0, because if denominator vanishes, that is absurd. Okay, so the final answer is x belongs to open interval minus 5 5 excluding 0. Write down. Write down this. Now second sum, let me explain first. What is f of x? It is x cube minus 9x square plus 24x plus 12. So what is f dash of x? You should be able to write derivative directly. 3x square minus 18x plus 24. Take 3 common. So x square minus 6x plus 8. Now x square minus 6x. See, I am talking about these two terms. This can be perfect square of what? X minus 3. Square this. X square present minus 6x present plus 9, which is not there. So I subtract 9. But originally plus 8 was there. So I have to write that. So effectively this is 3 into in bracket x minus 3 bracket square minus 1. Now for strictly decreasing function, first derivative should be less than 0. So that gives me 3 times x minus 3 square minus 1 less than 0. Divide by 3. So x minus 3 square minus 1 less than 0. How to solve this inequation? X minus 3 bracket square less than 1. See, x square less than a square means minus a less than x less than a. So in this case, it will be minus 1 less than, don't say x because it is x minus 3, less than 1. Now add 3 because we want for x. So if you add 3, minus 1 plus 3, 2, less than x, less than 1 plus 3, that is 4. So function is strictly decreasing if x belongs to open interval 2, 4. Right now. This is not at all difficult. What is difficult is solving an inequation. Right now. Yes, now we will discuss an interesting concept of maximum and minimum value. Actually, maxima is plural of maximum and minima is plural of minimum. Okay. Now, see this graph. You will notice this is graph of basically y equal to fx. You will notice that the function f increases from the left up to c. This is the point c. Function f increases from the left up to c and decreases to the right of c. Okay. Now, what are the criteria for function to possess maximum value? Actually, there are two different tests: first derivative test and second derivative test. Now, second derivative test is easy to apply. So in exam, we will be using second derivative test only. But in some cases, second derivative test fails. So in that case, you have to go for first derivative test. Actually, I will explain both the tests. Okay. Now it can be seen that function possesses maximum value at c. Of course, In which interval? I have explained this while explaining the concept of increasing and decreasing function. This is neighborhood of C. C minus delta, open interval C minus delta, C plus delta. What is delta? It is very small but positive real number, so that C minus delta lies to the left of C and C plus delta lies to the right of C. Okay. Now let us discuss first derivative test. Now I consider 2 points C minus H, C plus H, both belonging to the open interval C minus delta, C plus delta. That is, I will say C minus H, C plus H, they belong to the neighborhood of C, such that C minus H is less than C plus H. Okay, we are now in a position to discuss first derivative test. Clearly, tangent drawn at point C, tangent drawn at point C is parallel to x-axis. So what will be the slope of this tangent? 0. But slope of the tangent at x equal to C is f dash of C. So f dash of C has to be 0. Now note that C minus H lies on which part of the graph? Increasing. But for an increasing function, first derivative, this is basically strictly increasing at this point. So first derivative is positive, and that is why I have written f dash of C minus H greater than 0. Now you will notice that at C plus H, the function is strictly decreasing. And for a decreasing function, first derivative is less than 0. That's it. This is called as first derivative test for maximum. Now you will ask me, sir, what is the value of H? See, H is very, very small but positive real number. Okay. So I repeat this. A function y equal to fx is said to have the maximum value at x equal to c if f dash of c equal to 0, f dash of c minus h is greater than 0, and f dash of c plus h is less than 0. Okay, so this is first derivative test. Let us discuss second derivative test. This part is again interesting. Now second derivative test can be applied very easily. I'll explain. It can be seen that c minus h is what? Less than c plus h, because this much is c minus h and this much is c plus h. Now consider the function f dash. F dash of c minus h is positive and f dash of c plus h is negative. So I can say that c minus h is less than c plus h, but f dash of c minus h being positive is greater than f dash of c plus h. Now you must remember that this happens in case of decreasing function. See, this is graph of which function now? F dash, because we know that f dash is again a function of x. So c minus h less than c plus h. But what is f dash of c minus h? It is greater than f dash of c plus h. So you will notice that f dash is decreasing function. And what is the criterion for decreasing function? Its first derivative is less than 0. Now first derivative of which function? F dash. So derivative of f dash is f double dash, and therefore we say that f double dash of c is less than 0. So if I ask you what is the second derivative test for maximum value, your answer should be f dash of c should be 0 and f double dash of c should be less than 0. Then and then the function is decreasing function. Let me explain minimum also, then I'll repeat this part. So decreasing function. Now you can observe that in this case, in the neighborhood of C, the function has minimum value. See, I'm using the word local minimum. I'm not saying least value of the function, because I have not drawn the graph of the function over complete domain. I'm considering a very small interval. So in that neighborhood, I can definitely say that function has minimum value, and therefore we have to use the word local minimum. And in the previous case, local maximum, not global, local, not the greatest value, local maximum. So in this case, local minimum. You can observe that function decreases from the left up to C, and what increases to the right of C. Okay, so if somebody asks you to define the local minimum, how will you define? A function f is said to have a local minimum at x equal to C if in some neighborhood C minus delta C plus delta of C, the function decreases from the left up to C and increases to the right of C. So in this case also, we will be using two tests. The first one is first derivative test, and second derivative test. Now, tangent drawn at x equal to C is parallel to x-axis. So slope of the tangent equal to 0, but slope of tangent is f dash of c. So this is the basic criterion. F dash of c must be equal to 0. Now observe that c minus h lies on the graph which is decreasing, and c plus h lies on increasing graph, right? Now, for a decreasing function, first derivative is less than 0, and that is why I have written f dash of c minus h less than 0. But c plus h lies on this part of the graph, increasing function. So first derivative at c plus h is what? Actually, this should not be f double dash. I'm sorry. It should be f dash only. Okay, now this is correct. So f dash of c plus h is greater than 0. Okay, so this is the first derivative test. Now second derivative test is also interesting. See, f dash is again a function which is differentiable, right? So f dash of c equal to 0, this part is going to be there. C minus h is less than c plus h. Now f dash of c minus h is negative and f dash of c plus h is positive. So I can say c minus h less than c plus h, but f dash of c minus h is less than f dash of c plus h. You will notice that this happens in case of increasing function. See the diagram, c minus h less than c plus h, and the function is f dash. So f dash of c minus h is also less than f dash c plus h. This means f dash is an increasing function. For an increasing function, derivative is greater than 0. So what is derivative of f dash? Derivative of f dash is nothing but f double dash. So what is the second derivative test for minimum? That f dash of c must be 0 and f double dash of c must be greater than 0. Now there are three possibilities about second derivative at x equal to c. First possibility, second derivative is negative, so function has maximum, local maximum at that point. Second possibility, f double dash of c positive, function has local minimum at that. Of course, f dash of c has to be 0 in the first case and in this case also. Now the third possibility is f double dash of c equal to 0. So in that case, the second derivative test fails. So we have to go for first derivative test. We'll be solving around 30 plus sums. Hardly one or two sums you will notice that the second derivative test fails. Otherwise, in most of the cases, we can easily apply and use second derivative test. Okay. So what is the procedure for finding maximum or minimum value? We will be discussing second derivative test at present. So the first step, find out f dash of x and f double dash of x, because we require both. Okay. Then find roots of the equation f dash of x equal to 0. Why? Because we are interested in points for which first derivative is 0. Okay. So we solve the equation f dash of x equal to 0. If c is a root of this equation, Then find f double dash of c. If f double dash of c is less than 0, then the function has maximum, local maximum at x equal to c. And if f double dash of c is greater than 0, then the function f has a local minimum at x equal to c. Now we use the same procedure for the other roots of the equation f dash of x equal to 0, because we have assumed that c is one of the roots of that equation. Okay, I hope you understood the concept of a local maximum and local minimum. Okay, now fourth sum. What is f of x? 2x cube minus 15x square minus 144x, okay, minus 7. Find out f double dash of x. This is not difficult. This is 6x square, okay, minus 30x minus 144. Now can we take 6 common? Yes, we can. So this is f dash of x. So f dash of x is nothing but, if I take 6 common, I get x square minus 5x minus 24. Okay. Now f is strictly increasing. Before that, I will simplify, because we will be using this for decreasing also, uh, again for increasing also. Okay. So how can I simplify this? I write this as 6 into, see, this can be perfect square of what? X minus 5 upon 2. Why upon 2? Because when you square, it is 2 times the product. Now check this. This is x square present minus 5x present plus 25 by 4, which is not there. So you have to subtract. So minus 25 by 4 minus 24 as it is. Okay, so this is nothing but 6 in bracket x minus 5 by 2 bracket square. What is LCM? 4. So minus 25 minus 96, that is what? 1 to 1. So minus 1 to 1 upon 4. Yes. Now this is what? F dash of x. Now part A. In part A, what is asked? Increasing or decreasing? Increasing. So I will say f is strictly increasing. Write down. Strictly increasing if f dash of x greater than 0, that is 6x minus 5 by 2 square minus 1 to 1 by 4 greater than 0. Now solve this. Tell me what you get. So x minus 5 by 2 square minus 1 to 1 by 4 greater than 0. That is x minus 5 by 2 square greater than 1 to 1 by 4. Now here I will write how to solve this in equation. I will say y square greater than a square means what? Y less than minus a, or y greater than a. I have used variable y because here it is x minus 5 by 2. Okay. Therefore, x minus 5 by 2 is less than, what is square root of 1 to 1 by 4? It is 11 by 2. So less than minus 11 by 2. Use the word or and not and, because simultaneous occurrence is impossible. Greater than what? 11 by 2. Now simplify this. This is not difficult now. So x less than what? Minus 11 by 2 plus 5 by 2. That is minus 3. So x less than minus 3 or x greater than what? X greater than 8. Now can you combine this? Even if you write this as the final answer, you will get full marks, or I will say that is x belongs to open interval minus infinity minus 3 union open interval 3 infinity. So f is strictly increasing for x less than minus 3 or x greater than 8. So this is the answer. See, we have to make use of this part directly for finding decreasing function. Now B part, strictly decreasing. See, we can use this directly. What is f dash of x? We have simplified f dash of x as 6 into this. Okay. So it has to be less than 0. That is x minus 5 by 2 square. I will directly write less than 121 by 4. Which is perfect square of what? 11 by 2. Now tell me how to solve this inequation. I will again write here at y square less than a square means minus a less than y less than a. So I will say that is minus 11 by 2 less than x minus 5 by 2 less than 11 by 2. Add 5 by 2 to both. In fact, to all the three. So that gives me what? Minus 11 by 2 plus 5 by 2. That is minus 3. So minus 3 less than x less than 8. So the function is strictly decreasing if minus 3 less than x less than 8. Now we can also show this by rather on number line. Minus 3, 8 are stationary points. In between minus 3 and 8, function is decreasing. To the right of 8 and to the left of minus 3, function is increasing. That's it. So this is about sum number 4. Now go for sum number 5. See, what is f of x? It is x upon x square plus 1. What is that sum? Find the values of x for which fx is strictly increasing, strictly decreasing. Similar. So what is f dash of x? Here you have to use quotient rule. Denominator x square plus 1 into derivative of x, which is 1, minus numerator x into derivative of denominator. What is derivative of denominator? It is 2x upon denominator square. Okay. Now can denominator be 0? Never, because x square plus 1 cannot be 0. So if I simplify this, what is f dash of x? Tell me on simplification. It is x square plus 1 minus 2x square. That is 1 minus x square upon x square plus 1 bracket square. Okay. Now for strictly increasing function, first derivative has to be for increasing function, first derivative has to be greater than 0, strictly increasing. And for strictly decreasing, first derivative must be less than. Complete the solution. So 1 minus x square upon x square plus 1 bracket square is greater than 0. Multiply by x square plus 1 bracket square. So that gives me 1 minus x square greater than 0. Now you have to solve this in equation. That is 1 greater than x square. That is x square is less than 1. If I call this as mouth and this tail, so tail is towards 1. So if you write x square first, again tail has to be towards 1 only. So x square less than 1. Now how to solve this in equation? That is, I will say, that is minus 1 less than x less than 1. So for all values between minus 1 and 1, the function is strictly increasing. Now find out for decreasing. In fact, from the number line, we can find out that for x greater than 1 or less than minus 1, function is strictly decreasing. But in board exam, you have to write this. In CET, you can directly write the answer. So 1 minus x square less than 0. That is 1 less than x square. If I write x square first, then x square greater than 1. That is x less than minus 1 or x greater than 1. Therefore, we have to say x belongs to open interval minus infinity to minus 1 union 1 to infinity. Right down. So in sum number 6, fx is 3x plus 1 upon 3x. What will be f dash of x? It will be 3 minus 1 upon 3x square. Is it correct? Okay. Now I will write f is increasing if f dash of x is greater than 0 and is decreasing if f dash of x is less than 0. Okay. Now I will say, you first write down this. I will dictate. You write down this. That write down. Now f is increasing. Write down. Now f is increasing if f dash of x is greater than 0 and is decreasing if f dash of x is less than 0. Okay. Now first part, let x belongs to 1 upon 3 1 open interval 1 upon 3 1 means what? 1 upon 3 less than x less than 1. Now just give me 2 minutes. Let me explain. I'll give you time to write the solution. See, we have to prove what? The function is increasing in this means derivative for this is definitely greater than 0. Now we will try to obtain, let me complete. We will try to see the position of cursor. We'll try to obtain f dash of x in place of x. We had done this in 11th standard, given the domain, how to find range. So instead of x, I will try to obtain what? 3 minus 1 upon 3x square. Okay. Now we need square. Therefore I will say 1 upon 9 less than x square less than 1 ka square, which is 1. Is this correct? Yes. After this, we need 3. Therefore, multiply by 3. So, 3 by 9 means 1 by 3 less than 3x square less than 3. Is this correct? Now take reciprocal. Remember, if reciprocals are taken, inequality gets reversed. I will give you one example. And for that, what is the requirement? Both have the same sign. Means what? See, 3 less than 4. Take reciprocal. 1 upon 3 is greater than 1 upon 4. Okay. Therefore, if I take reciprocals, then 3 greater than 1 upon 3x square greater than 1 upon 3. This is not at all difficult. We are trying to get f dash of x in place of x, but we need minus, so multiply by minus. Again, if multiplied by negative number, inequality changes. So this is minus 3 less than minus 1 upon 3x square less than minus 1 upon 3. Example, 5 greater than 1, but minus 5 is less than minus 1. This is the simple logic. Have we obtained f dash of x? Not yet. We have to add 3. We have to add 3. Then only we will get. So if you add 3, you get what? You get minus 3 plus 3, that is 0, less than 3 minus 1 upon 3x square less than minus 1 upon 3 plus 3. Okay. So in the next step, I will say 0 less than, this is f dash of x. 0 less than f dash of x less than 8 by 3. Okay. And therefore, I can say, therefore, after this, I will say, therefore, f dash of x is greater than 0 for all x belonging to, what is the open interval? 1 upon 3, 1. Okay. I'll explain this part once again. Then I'll give time to write the solution. See, right from the beginning. We begin with fx, 3x plus 1 upon 3x. So what is f dash of x? 3 minus 1 upon 3x square. Now we begin with this interval. See, this is domain. X assumes values between 1 upon 3 and 1. So 1 upon 3 less than x less than 1. Now in place of x, we have to obtain f dash of x step by step. First I square, then I multiply by 3. Okay. Then what is the next step? Reciprocal. Reciprocals are taken, inequality reverses, but we need minus. If multiplied by minus, inequality reverses. We have to add 3. So we get this. But this is f dash of x. So f dash of x is greater than 0. So in this particular interval, function is definitely an increasing function. Okay. Now write down. Okay. Now second part. Let x belong to open interval 1 by 9, 1 by 3, that is 1 by 9 less than x less than 1 by 3. So 1 by 81 less than x square less than 1 by 9. Therefore, multiply by 3. So 3 upon 81, that is 1 by 27 less than 3x square less than 1 upon 3. Reciprocals. So 27 greater than 1 upon 3x square greater than 3. Now we need minus. So minus 27 less than minus 1 upon 3x square. Okay. Then what? Less than minus 3. Good. Now next step, we have to add 3. minus 27 plus 3 less than 3 minus 1 upon 3x square less than minus 3 plus 3. Therefore, minus 24 less than f dash of x less than 0. And we need this only. What? F dash of x less than 0. Therefore, I can say f dash of x is less than 0 for all x belonging to which interval? 1 upon 9, 1 upon 3. Therefore, f is decreasing. F is decreasing in open interval 1 by 9, 1 by 3. That's it. In fact, in the first part also we should have written, therefore f is increasing in the interval 1 upon 3, 1. If not, if you haven't written that, please write that. Now, next sum number 7. Show that f of x equal to x minus cos x is increasing for all x. What is fx? X minus cos x. So what is f dash of x? It is 1 plus sin x. Now, for all x belonging to R, sin x lies between minus 1 and 1. But we need 1 plus sin x. So we add 1. Minus 1 plus 1, 0. 0 less than or equal to 1 plus sin x less than or equal to 2. Okay. So f dash of x is definitely greater than or equal to 0. So function is increasing for all values of x, for all real values of x. Right. Okay, then we'll stop here. We'll continue tomorrow.